Alright guys, so I told you that we were going to be moving into logarithms, and the reason that we talked about inverses first and exponential second is because logarithms are the inverses of exponential functions. So if you think about some exponential function that's defined y equals a to the power of x. So when you take the inverse, right, you switch x and y, so you get x is equal to a to the power of y. And then remember, when we're looking for an inverse function, we now have to solve for y. Well, the way that we solve for y is with a logarithm. So as this piece here says, as long as a is not equal to 1, right, because we said anything with a base of 1, 1 to any power is 1, so it's not exponential. As long as the base isn't 1, then if you have x is equal to a to the y power, then in order to solve for y, you take what's called the logarithm base a of x. The logarithm is an exponent. The expression log base a of x represents the exponent that you raise a, so a to some power will give you x. And that's what a logarithm means. So if you take a look at the logarithmic form compared with the exponential form, the base, the little number, becomes the big number, the base. And then the exponent, y, goes as your answer, and the answer, x, goes along with that log. And that's actually how you're going to think about the way that this logarithm works. So let's take a look at what's going on here. These are some that we should be able to understand. So if I have log base 2, there's base 2 of 8. Well, 8 becomes my answer, and then it's equal to 3. 3 becomes the exponent. So really I think of like 8 and 3 sort of switch places. The 3 now goes with the logarithm where 8 now goes by itself. If you have logarithm base 1/2, you can take the power of 1/2. We have negative exponents, that's perfectly fine too. We can do all of these base 10s. That's going to become very important. And then, of course, when we're dealing with zeros, the log of any base of 1 must equal 0 because anything to the 0 power equals 1. So now we get to do a few problems to practice. So we'll start here. The log base x. Base x becomes my big number. The 16/9 and the negative 2 will switch places, so that negative 2 goes with the x. That's going to be equal to 16/9. Well, this is kind of tricky because suddenly we have a negative exponent. Well, we know how to deal with negative exponents. It's a reciprocal. So we could say that x squared would then equal 9/16. And then we could take the square root of both sides, and we'll find that x is equal to 3/4. And you're thinking, Mrs. Busselmeyer, it's supposed to be plus or minus. Remember that when we're dealing with logarithms, we're not going to have any negatives in this particular case. You can always check. So you can say, okay, well, I'm just going to put everything back into this here. So 3/4 to the power of negative 2 is equal to 16/9. Well, 3/4 to the negative 1 squared would then be 16/9. It should not say 19ths right there. 3/4 to the negative 1 is 4/3. And it does work. Let's take a look at the next one. Here we have log base 16 to the 3/4 power is equal to x. So that's the same as saying 16 to the 1/4 power cubed is equal to x. Well, if I'm thinking about 16 to the 1/4 power, I'm probably thinking of the 4th root of 16. And then cubing that number. And if I'm thinking about the 4th root of 16, I probably want the prime factorization. And amazingly enough, the 4th root of 16 is 2. So I have 2 cubed is equal to x, and 2 cubed is 8. And for our final example here, the log base 36, that becomes my big number, to the power of x is equal to the square root of 6. Well, so what number does x have to be in order to make this work? Well, if x is 1/2, then I get 6, right? So 36 to the 1/2 would give me 6. So I need 6 to the 1/2. So I need 36 to the 1/2, because that's the same as 6, to the 1/2 to equal the square root of 6. Okay, well, power of a power means that I have to multiply these two exponents together. So that means that I need 36 to the 1/4 power to equal the square root of 6. So in this case, x is equal to 1/4. Just like we had properties of exponents, we have properties of logarithms, and they're actually going to be kind of similar. The first is the product property. That means if you're taking the log with some base of two numbers that you're multiplying together, what you can do is you can separate it so that you have the log to that same base of the first number plus log to that base of the second number. This works backwards, but remember, just like with exponents, the bases absolutely must be the same. So here, if I have log base a of x plus log base a of y, I can combine those together to get log base a of x times y. Obviously, if there's a product property, there's also a quotient property, and just like you might think, because dividing is the inverse of multiplying, subtraction is the inverse of addition. So if we have log base a of some fraction, we take log of that base of the numerator minus log to that base of the denominator. Now it looks to me like this slide that I copied is messed up, so scratch this out, and what I'll have you put is log base a of x to the r power. So that's actually going to be the power property. Whoever typed these was terrible. So what you can do here is you can take this exponent and move it out to the front. When you do that, you get this. And again, the reverse will also be true. So now let's take a look at a few of these properties. We're going to start with some simple ones. The next set will definitely be harder. So first we've got product property, right? We're multiplying 8 and 6 together. So what I'll do is I will have log base 7 of 8 plus log base 7 of 6. That's how we do that. Quotient property, going to be the same kind of thing. Log base 6 of 12 minus log base 6 of 5. Now, you're probably thinking, you told us there was a power property, and I don't see a power, I see a cube root. Remember that cube roots are powers. This is the same as saying log base 2 of 9 to the 1/3 power. Now I have a power, and what I can say, let me bring that 1/3 out front, log base 2 of 9. These definitely look a lot creepier. course they do, because we no longer have those nice things that we've been thinking about. We now have all these letters that we're dealing with, but the rules still apply. And let me assure you that this is where you will make your mistake. This will be on your test. So I'm going to start with my numerator. Okay, all of these things get multiplied. Get added. All of these get subtracted. So I'm just going to start with the numerator. Log base b of r. Log base b of s squared. Log base b of t. Minus. Gonna put this part in parentheses. So these things are being multiplied, although it's all in the denominator. When I distribute this negative, it will all end up being negative. So I have log base b of u cubed and log base b of v to the fifth. So now I've dealt with my product property and my quotient property. Now I have to deal with the power property. The first term will stay the same. Log base b r. The second term, however, that 2 gets moved out front. So I have 2 log base b of s, and then log base b of t will stay the same. Now I will distribute this negative, so that becomes minus. This 3 comes out front. 3 log base b of u. Distributed the minus, right? So that's again a minus. And then this exponent here of 5 will also come out front. 5 log base b of v. This is my answer. Let's try the next one. Again, we're going, okay, wait a minute, I have a power. What do I do with powers? So we'll start with rewriting it in a way that makes more sense. Log base a of r cubed to the 1/5. Okay, well, I can work with this because I know some rules. I know if I take power of a power, I multiply my exponents. So that's going to be the same as log of base a r to the 3/5 power. Well, now it's really simple. I just go with my power property, and I take that exponent and I bring it right out front. So I get 3/5 log base a of r. Alright, so now we're going to do this last one that is, again, kind of combining everything, including this awful nth root, which nobody ever wants to deal with. So the first thing that I do is I rewrite this in a way that will make the most sense. So I have log base a, r cubed, s squared over t to the 4th, and this is all to the 1 over m power. Okay, I can deal with 1 over m power because all I do is I bring that out to the front. And then everything else will go in the parentheses. So I have log base a, r cubed, log base a, s squared, minus log base a, t to the 4th. Okay, now I'm going to bring all of those exponents that I have here. I'm going to bring each one of those out front. So I'll keep my 1 over m here. My giant parentheses, this becomes 3 log base a of r, 2 log base a of s, minus 4 log base a of t. And then the very last thing that we do is we distribute that 1 over m to each one of these. And what that looks like is, so 1 over m times 3 is 3 over m, log base a of r, 2 over m, because 2 times 1 over m is 2 over m, log base a of s minus 4 over m log base a of t. So we survived these problems, but you do need to do them step by step. You absolutely must take your time, and if you if you rush, you absolutely will make mistakes. So just like we were able to use the power rules to separate logarithms, we can actually go backwards. So let's take a look at the first problem here. Notice that everything is base 4, which is why we're actually allowed to do this. If they were different bases, we wouldn't be able to do anything. So what I'll do is I'll write this in as log base 4. That's a terrible base 4. Let's try that again. Now, this first term is positive. That means that x goes in the numerator. The next term is negative, so y goes in the denominator. And then the last term is positive, so z goes in the numerator. That's it, we're done. Taking a look at the next problem, we should notice that we've got some power rule things happening here. And we should also notice that we've got a subtraction sign, which means that there's a fraction. So what I'll do is I will write this out in stages. First, I will move these coefficients into the exponents where they belong. So we'll have log base b of r to the 4th minus log base b of s to the 5th. Now I will write this as the fraction. Log base b, r to the 4th, that's our numerator, s to the 5th is our denominator. This last one I'm going to leave for you. What I will do is I will tell you that this 1/3 here and this 2/3 here is going to show up as a cube root. So I would like you to think about the fact that you have log base a x to the 1/3 log base a y squared to the 1/3 minus log base a of xy. So that's some place for you to start. I do expect you to have this completed. You should be able to move on from here. Good luck.